Hi, grade 11s. Today we'll be looking at identities and simplification of trig expressions. The identities that we'll be looking at or working with are these ones. The tan of theta is equal to sine theta over cos theta. The other one is sine squared theta plus cos squared theta equals 1. These you'll need to remember and keep it in mind whenever you are doing or simplifying trig expressions. From here, we can prove this. Therefore, we can do a square this side here and get something like tan squared theta would be equal to this side squared would be sine squared theta over cos squared theta. Again, if this is true, we can therefore take the cos squared theta to the other side, and then we can also be left with sine squared theta the same as 1 minus, take this across, is cos squared theta. If I didn't take this, I could have taken this to the other side, then I could have had cos squared theta is same as 1 minus sine squared theta. You will see when we simplify some of the expressions when we use these things. Let's look at some examples. Here's example 1. They say here, simplify cos theta times tan theta. So I've got to simplify this. Let's rewrite this. This is cos theta, which is multiplied by tan of theta. Now, tan, we said it can be written as sine theta over cos theta. So this becomes now cos of theta multiplied by sine theta over cos theta. I'm replacing tan theta with sine theta over cos theta because we said tan theta is sine theta over cos theta. So now you can see that because there is a times there, so I can cancel the same factors there, it goes once there. So my answer for this one is 1 times sine theta, which is sine of theta, divided by 1, and the answer is equal to sine of theta. Done. Full marks. Let's look at another example. Let's say they want us to simplify this. Let us rewrite this. So I've got sine theta minus cos squared theta times sine theta. It is always important that you know how to use your basic algebra in simplifying expressions. If you look here, I've got two terms. There's a common factor between the two terms, sine theta. So I can factorize this and say I've got sine of theta, open the bracket, close the bracket. So sine theta divided by sine theta give us 1. The minus cos squared theta times sine theta will divided by sine theta will give us minus a cos squared theta. Now look at this, which is inside the bracket, something that's familiar. We said there, if you look, check, we said sine theta can be written as 1 minus cos squared theta. So 1 minus cos squared theta is sine squared theta. So this thing is sine squared theta. So this is sine of theta, which is multiplying the sine squared theta. Now sine theta times sine squared theta is sine cubed theta. Done. Let's look at another example. As long as your algebra is good, these things gets easier. But you can practice even if you're struggling. Let's look at this one. I'll use one method which will stick to what we are doing here. Alright, let's take this thing here. I've got to simplify this expression. Let's write it as cos squared theta over sine squared theta, bracket 1 over cos squared theta minus 1. And you remember that the laws of mathematics say you must always try and find the answer inside the bracket first. So I've got cos squared theta over sine squared theta. So I need to find out what is the answer here. You can see these are fractions, means that we need a common denominator, which will be a cos squared theta because this is over 1. So now I've got 1 over cos squared theta minus 1. So I must multiply this with a cos squared theta over cos squared theta so that the denominators are the same. So these must be the same, right, that I'm multiplying with, so that they make 1, doesn't change it then. So this is now cos squared theta over sine squared theta, and now they've got the same denominator, which is what? Is cos squared theta. This is cos squared theta. So there on top I've got 1, and here it's minus 1 times that is minus cos squared theta. then close the bracket. Now that thing is familiar thing that is on top there. It's 1 minus cos squared theta. 1 minus cos squared theta is sine squared theta. So this becomes a cos squared theta over a sine squared theta. Then there is sine squared theta over the denominator, which is cos squared theta. Now we can rewrite this because we saw that I've got bracket. I can remove the brackets there, and sine squared theta. This is multiplying that, which is sine squared theta over cos squared theta. Check what happens. The cos squared theta once, cos squared theta once, sine squared theta once, sine squared theta once. What am I left with? I'm left with 1 times 1, 1 over 1 times 1, 1. And my final answer is 1. Let's look at the last problem maybe. Simplify this one. Let's look juicier. So we've got to simplify this. Let's check here. So this one right here, I've got a sine of theta over 1 plus cos theta, which is added to 1 plus cos theta over sine theta. Now, you can see that the denominators are not the same. I want the denominators to be same. This is 1 plus cos theta, this is sine theta. So what am I going to do? I'll multiply this one here with sine theta over sine theta, because that is 1. If you multiply by 1, you're not changing the value of what is given there. This one must also be multiplied by 1. What would be 1? Remember that we want the denominators to be same. This one already has got sine, so it means that I must use this one here. So I've got 1 plus cos of theta over 1 plus cos of theta. Now you can see that the denominators are now the same. So I've got a long line there. So it's this thing here, which is 1 plus cos theta, which is multiplying a sine theta. It's the same as that one. Is 1 plus cos theta and sine theta. So what's left there on top? So the sine theta will multiply sine theta, giving us a sine squared theta. Now this will multiply again. Remember, these are two brackets here. So this will multiply that. Let's do it all together. 1 times 1 is plus 1. 1 times cos theta is plus cos theta. Now cos theta times 1 is plus cos theta. And cos theta times cos theta is cos squared theta. Now, can you see sine squared theta and cos squared theta? We can group them and put them together. I've got sine squared theta plus cos squared theta, then a plus 1 plus cos theta plus cos theta. So all of this is being divided by 1 plus cos of theta times sine theta. On top you can see the like terms. Now sine squared theta plus cos squared theta, we said sine squared theta plus cos squared theta is just 1. So I can just replace this thing here with a 1. So this is 1, then plus 1, and this like term cos theta plus cos theta is 2 cos of theta. So this thing here is being divided by 1 plus cos of theta times sine of theta. Now 1 plus 1 is 2. So on top I've got 2 plus 2 cos of theta, which is divided by 1 plus cos of theta sine of theta. Now if you look at there on top there, I can factorize that. If I were to factorize that, let's check what we see. There's a common denominator there. What is it? It is a 2 into 1 plus a cos theta divided by, this is in bracket there, the 1 plus cos of theta, then times sine of theta. So what will happen now? Let's check what's happening. There we go. This cos theta, 1 plus cos theta, cancels that 1 plus cos theta. That goes once, that goes once. So what am I left with on top there? So I'm left with 2 times 1 is 2 over sine of theta over sine of theta. That's an answer. Okay? So ladies and gentlemen, if you can try some of the problems that are meant to be used from Siavula textbook, Maths, Chapter 6, Trigonometry, 6.2 says trigonometric identities. Exercise 6.2, just do numbers 1, A, B, C, and D. Then next time we'll be doing more of the identities. Good luck.